Greetings, Alex Kennis here again. Welcome to the next edition of the Ender series. Now, sorry about the long time it's been taking to get these couple videos out. Just been super duper busy. And I know I promised a little while ago I would get at least a board review out. And unfortunately, I started that and it got thwarted by... Hit the microphone there. Well, I got in contact with some of the manufacturers and got revised versions of the boards in, so hopefully I'll be able to get one of those out real soon. I want to get them out by the 11th because AliExpress and Banggood and all those big places, they're having their 11/11 sale. So hopefully there will be some pretty good deals there. If I go through all this and there aren't good deals, that would suck, but that's just for the sake of you all. So hopefully I can get that done, and hopefully I can get some kind of affiliate links or something for you all and get your boards cheaper, or maybe a discount code or something like that. I'll see what I can do. I have a couple days. Anyway, I realized I couldn't put that video out until I had at least done the rest of the assembly video, which is this one right here. So we had the live stream where you watched me trying to fumble it and put it together with the instructions, and then I did the basic, impressions and unboxing video and that type of thing. So the rest of the nuts and the bolts videos have to do with after the construction, we have the adjustments of the printer. Then we have the power supply, which I'll have to do that as well before I move on to electronics. But then comes the electronics, and then I can start doing upgrades and modifications and things like that. But anyway, this one I wanted to do because if you did watch the live stream, or if you know anything about these printers, you know that there's not really a procedure for getting the whole printer square and adjusted properly. And I said in the live stream, I YOLO Supermaned it to level the gantry because I didn't realize there wasn't some kind of procedure and you couldn't get to all those screws in the back. So I bolted the whole thing together and I was like, it's not level. Just level it out like that. Obviously, that's not the best way to do it, although it was effective. So there's a ton of guides for this type of thing online, other videos on YouTube, and there's some PDFs you can get from the Ender Facebook group, the unofficial Ender Facebook group, and things like that. But I thought I would just put this video out and show you the way I did it. So this is not by any means a definitive guide. This is just the way that I thought it would be the most useful. And even before I got the printer, I was scheming ways that the layman could, without expensive gear and things like that, get a good adjustment on the printer, and then that's the philosophy is sort of carrying on into the rest of the series. So anyway, yeah, that's all to say that don't take this as a definitive truth, and if you like any of those other methods, that's fine too. But I'll show you what I did, show you why I did it that way, and then walk you through it step by step. All right, here we go. Now, I like to use a time index, particularly for longer videos, so check the video description to skip around to the sections that you're interested in. However, watching the entire video will give you a better idea of the different options as they compare and contrast to each other, but feel free to skip around. Basically, when you're talking about these types of mechanical systems, you have a range anywhere from perfectly adjusted but rigid and you can't mess with it, all the way to way off, but you can adjust it as needed. So in terms of this printer, there are three main problems when it comes to getting the thing adjusted after you bolt it together. One is the alignment of the vertical extrusions. That may or may not be a problem. We'll get to that. Two is the Z lead screw alignment, that is aligning it with the motor shaft. And three is leveling out the X gantry. And we'll touch on all those three sections. Conveniently, Creality's released all of the CAD files for this printer, so I could just dump it into a CAD and use this as an example. So I'm just going to pull this frame here and rip out the pieces that we need to do an illustration for this alignment. And I'll just be using this still right here to demonstrate the various areas of the printer we're interested in. So point number one, the vertical extrusion alignment. Now, this is two parts. One is, are the vertical extrusions cut properly? And the second is how to get them aligned when you put them on the printer. So first off, be ye sure that these are the same length and that the ends are cut square and flush. Easiest way to do that without precision measuring tools is just to lay them on top of each other and make sure that they're square and flush and the same length and all that stuff before you start, which will become important later on. So there are two different ways that this could be off. One could be misalignment and the other could be rotation. So misalignment like this is not as big a deal because we can adjust the distance from the one wheel card on the left side to the other wheel card on the other side. What's much more important is, if we're looking at this from the top, making sure that this is not rotated all goofy, because that's going to affect the operation of wheels, our ability to get all 3 wheels on each side touching, and that sort of thing. So the simplest way that I could think to do it, and this was suggested by somebody in the live stream comments as well, is just when you're assembling this, these red parts are the vertical extensions right here. They slide down onto these, which we'll just call the legs, and then they bolt through. Just kind of finger tighten those bolts so that everything's there, but you can still adjust it a little bit. And then just lay it on a nice flat surface when you tighten those down. That'll at least pull them against each other, make sure that they are in line with each other and flush, and that should be good enough for our adjustments. Look, I know this is obvious, but everyone out there might not be as smart as you, so I have to put this kind of section in here. Shh. And if you want to make sure that these sides are lined, it's pretty simple to just take any kind of flat object and put it against the side here while you have it lying down on the flat table before you tighten down the bolts. Okay, so we got the simple stuff out of the way. Let's move on to the stickier things. Number 2 is the Z lead screw alignment. Now, first thing, this is very important for what we're going to be doing, unplug yo Z motor. Fortunately, they use these JST connectors. You could just unplug right at the motor body, and that's very convenient. So go ahead and do that. So folks that have had problems with the alignment on a Z-axis and the subsequent like binding and banding and things like that, if they didn't just assemble it or adjust it wrong, there are 3 major places where this breaks down to that we'll have to look at. One is the parts choice by Creality, the second is the parts quality from wherever they get those, and then the third is the manufacturing tolerance of the various assemblies and sub-assemblies. So as far as parts choice, what I'm referring to is this right here, which is the coupling between the Z-axis stepper motor and the actual Acme lead screw. They chose to use a rigid coupling, which is fine if everything is all well and good and perfectly in place. And I've done several videos about like these couplings and Z alignment and things like that you can check out if you want to. But the problem is that they're very unforgiving of problems. And since we don't live in a perfect world, usually a manufacturer would figure in that there's going to be tolerance issues or adjustment issues or runtime slipping out of adjustment issues, and they use some other type of more forgiving coupling. But this is an entry-level budget printer, so ideally they want to take 2 or 3 parts and roll them into the function of 1 part. So where the ideal arrangement will be a more flexible coupling and then a mount for the motor and a separate mount for a thrust bearing pillow that's going to take the weight of the gantry off of the actual motor shaft itself and allow for separate adjustment. That requires more parts, more complexity, and more possible places for user error in assembly. So they went with the rigid one, which works well enough in quotes if everything happens to be adjusted properly and within spec, but in future videos we'll explore some options with, like I said, pillow box and thrust bearings and alternate types of couplings. To illustrate the problem, if you're having a hard time visualizing it, let's say this top line is the lead screw and the bottom line is the stepper motor shaft. Well, if those are misaligned like this, obviously you're going to have problems with, binding and stuff like that. Also, if your nut happens to be shifted off from center line of your stepper motor shaft, then you are going to have it tilted at an angle where you're going to have these pressure points here and then here at the bottom, like little stress risers, where you're not going to get the nut moving as freely as it can to compensate for any inaccuracies. And as you can see right here, these nuts do have a little bit of play built into them, so they should be able to absorb that if they're not held at a bizarre angle. But another issue with these is that even though they look nice and cleanly machined to the naked eye, when you put them under a scope, you can see that, well, there are varying qualities of machining going on. This is my actual nut from Creality, which you can see is a little bit sketchy. There's also the quality of the machining on the rod itself. This is from my actual printer. It's not actually all that bad, but it's not as good as like the rod that I got from Open Builds that I use on my other printers. You can see how much smoother this is. But that's just all to say that you can see how the actual machining of the parts could lead to more or less binding, and you want to give that as best a chance to just be centered as possible and be able to float to compensate. And there are also various ways that you can make these nuts. Now, this is obviously machined brass, but a lot of them are sintered bronze, which are impregnated with oil and self-lubricating. There are also Delrin and Teflon or other low friction coefficient compounds that you can use for them. Since ours is just brass on steel, obviously it's going to need a little bit of lubrication because it's not self-lubricating, doesn't have a particularly low friction coefficient. Now, I've talked about lubrication in the past, and I have a vast assortment of lubes and oils and greases and that type of thing. But it's not as critical since we have sliding friction here as opposed to rolling like we do in something like a linear rail cart. So you can get away with using something that's a little bit more heavy bodied and you don't have to worry as much about like attracting dust and fouling up your bearings. So I have currently here about like 3 or 4 different printers set up, and I try to use like a different type of lube on the lead screws of each just to see how they hold up, and pretty much they've all worked fine. So some have lithium grease with Teflon in it, others are just like a light machine oil, others are synthetic oil with Teflon. For something as like light duty and non-continuous use as the Z screw on a 3D printer, it's not nearly as critical as like a high offset load, like high speed, like pick and place or CNC machine. So find something that's not too gloopy and messy, isn't going to break down and leave a sticky mess, preferably doesn't attract too much dust, isn't toxic, and preferably doesn't stink. A lot of people use like silicone or Teflon spray. That's fine. It's fairly thin and you'll have to reapply it occasionally. Other people use grease. Other people use like light machine oil. Like I said, I've used all those various things on various printers that are currently being used every day, and they all seem to work fine. I think I used Super Lube on the Ender 3. I'll have to go back to the video and double check, but that's just silicone with Teflon in it, and that should be fine. Now, when I assembled this, all I did to kind of like, quickie align it on the live stream was I left these bolts a little bit loose, like not completely finger tight, but a little bit loose so that the motor could move around a little bit, as well as leaving the nut a little bit loose, like leave these bolts a little bit loose so it'll knock back and forth, and then ran the Z-axis up and down a couple times to see where it wanted to naturally align itself, and then tighten them down. Now, obviously, that's not a perfect method, and it's not going to work if you have kind of poorly manufactured parts, but it was enough that I got a decent print without any, binding or banding or anything like that on the live stream. Ideally, the center line is represented by this red dot. As you move that up and down, you should see that the rod is not wandering to one side or another of it. And if you could see as I play this again, mine wanders ever so slightly, just a little bit. So let's talk about how we can systematically get this much more accurate. Now, as I had mentioned before, I wanted to go into this assuming that the builder didn't have a ton of money that they're going to spend, didn't have a bunch of fancy equipment. If you do, good for you. We should all be so blessed. But if you don't, I had to consider the variety of tools that you could use for something like this, as in like a depth gauge, a machinist square or an artist square, dial indicators, etc., etc. Ultimately, I decided to just jump onto like Amazon and see what like the cheapest reasonable thing would be. And you may have seen me refer to this on the live stream, but I picked this guy, which happens to be marketed as the tire gauge, but it makes a perfectly fine depth gauge as well. And it costs many, many times less than a decent dial indicator. Now, there are not decent dial indicators for like 20, 30 bucks. And I tried ordering a few of those like months ago, and they never made it over on the slow boat from China. So somewhere floating in the world are a couple dial indicators. But in addition to these being like super cheap and available like domestically just about everywhere, they also have these little diagnostic ports that you can plug in, and I don't know what kind of interface they use, but I'm sure somebody has decoded it since it's probably just a standard auto industry thing, and I want to be able to tie that into like a plotting program and use it for various things. And again, anything I say here, you can just substitute with, hey, why don't I use calipers instead? And I'll try to dig out stuff that looks decent and put like product links in the video description to all this stuff so you can take a look and make a decision on your own. But essentially, any device you use, principally, it's going to be about the same. We're just measuring the distance between the left side of our lead screw here and our vertical rail, which is going to be what our bearings are moving up and down on. So as long as that distance is the same at the top as it is on the bottom, you should be cool. But the problem I have with these guys is it's tough to get them flush unless you're really fiddly about it. Like, you can do it with your fingers, but here's an exciting product announcement. I decided to spend a little time with CAD to make your lives a little bit easier, and I developed something. So introducing the Creality Alignment Pack. It doesn't slice, it doesn't dice, but it'll align your printer super nicely. Because grammar is important. Act now and get a free nubbin thing and flat John. Simply print out the caliper base, slide in your tool, put on your nubbin of choice, and you're well along your way to a perfectly adjusted printer. Available at thingiverse.com, link in the video description. So hilarious infomercial jokes aside, I decided to design a little bit of a rig so that you can keep this square. But again, if you have the cash, feel free to shell out for proper tools. So here's the procedure. Step 1, make sure that your nut is just finger tight and you have a little bit of a gap here so that you can move it back and forth and adjust it as necessary. Step 2, take a baseline reading right down by the coupling on the Z-axis. That's what you're going to be shooting for across the entire lead screw. Step 3, try to match that measurement up top. And hopefully your bolts are tight enough that they're holding the position a little bit, but loose enough that you can still move them around. So tighten that down a little bit, and hopefully you're pretty close to parallel. Step 4, run the gantry up and down the Z-axis a couple times by hand to make sure that it's not binding anywhere. It'll move fairly quickly. Remember, we have our Z motor unplugged. And then recheck your measurements to make sure that everything's parallel. If you've done everything correctly, you should be pretty close. After just this one adjustment, I was within like 0.05 millimeters, which is pretty darn close. But if you didn't hit it on the first try, rinse and repeat. And then the last step, I say, take this and thread the axis up and down by hand just to make sure that it's not getting tight and binding at any point. And that'll let you know if there's an abnormality somewhere along the Z lead screw. So if all was done properly and you have decently manufactured parts, that should solve the whole crooked Z-axis problem. Now, if you have a gross misalignment problem like some people have, first, try loosening up these screws and moving the motor out as much as you can. If that doesn't give you enough adjustment, then you'll have to go ahead and put some shims around it or print out a new bracket. But just anecdotally from what I've seen from users, the majority of these problems can be sussed out on the majority of printers just with the adjustments. If you can't get that solved on your printer, then you probably got one where you have this bracket right here on the left side, the motor side, that was bent a little bit screwy. In which case you can use the flexible coupling plus ball bearing method that I used or that I mentioned in a previous video, and that could help you out. But I would definitely contact Creality and see if they can send you a proper bracket for it, because they should have replacement parts for these. So on to the third problem area, and that's the X gantry leveling. And man, this seems to be a big one, because if you're not aware of it, there's just no way you would know this could be a problem. And a lot of the hey, help me with my Ender threads that I've seen online, when people actually show pictures of their machines, the X gantry is skewed way off. So if you're not aware, what I'm talking about here is, let's imagine this is your 3D printing bed, and then this would be a flat plane along your 3D printing bed. Ideally, you would want your X gantry to be parallel with that, but often it isn't. So you get this weird skewed kind of thing, in which case you're never going to get a perfectly dimensioned and square print. Now, some people have gone as far to do a quickie fix by making the bed parallel with the X gantry, which is one step better to better print, but you're never going to get it perfectly square. You're going to still have a parallelogram print. So ideally, we don't want that. We just want to fix the problem. Now, the reason this is a big pain in the butt is because of the way this printer is constructed. There are 4 screws that hold the gantry in place and allow you to adjust it, and we'll just call those A, B, C, and D, moving from left to right, as in the motor side to the dummy side. After you've slid your X gantry onto the Z uprights, you can no longer access the A and the B screws, only the C and the D screws. And after we've put the top bar onto it, we can no longer slide the X gantry off of the Z uprights. So that makes for a very awkward situation. And one last term before I get into this, I'm going to call these large blue things down here that are the base of the printer the legs. So like I said, there are a lot of video and text guides on how to do this in various places, YouTube and Reddit and the Unofficial Ender Facebook group. So I'll touch on the basic premise of some of those, but I'm not going to go through those completely because you can find them somewhere else. I will eventually just show you how I chose to do it. So your choices are basically, you can align the gantry to the legs on the bottom of the printer, or to the top bar on the top of the printer, or use some kind of square. Now, I'm just going to go ahead and assume you don't have a square, because why would you be watching this video if you already had the proper gear? So there are potential pitfalls to each of the two methods, and again, there may be other methods, but of these two methods, if you align it to the legs, you'll have to remove the bottom electronics cover so that you can get the same length. And if you align to the top bar, as I mentioned at the beginning of this video, your Z extensions may or may not be equal length or squared on the ends. So that's why I said check that at the beginning. If they are square and of equal length, you're good. You can use the top bar method. Otherwise, you'll have to align to the legs. So first thing you do, slide the bed out of the way. Second thing, take off the bolts and remove your electronics cover so that you have a nice even surface. Then you could just take two equally sized objects, bring your gantry down to level it on them, and then tighten up the bolts. For example, right here, I just used two CD cases, one on each side, and then honked down the bolts. But remember, we can't get to bolts A and B, only C and D. So A and B are going to have to be, if you use this method and you leave the top bar off, tighten down adequately so that you could still move it, but it's not going to shift on you. Then you would bring it down on your two CD cases or whatever and tighten up the other bolts, as in bolts C and D. Then you would just slide the gantry back off the Z-axis upright extrusions and then tighten down bolts A and B, and you should be gravy. Now, one thing you have to bear in mind with this method is that we have to be able to adjust our wheels as well. And as I think your name was Christian, I'm sorry if I got that wrong, pointed out to me in an email, one thing that they hadn't seen mentioned anywhere else was that the wheels on the left and the right side tighten in opposite directions and pull against each other. So a lot of people run into problems where they tighten those down and then all 6 wheels don't touch the Z rails. So essentially, like, if you want to be able to adjust that independently, you can flip those bolts around and use T-nuts to mount it. Or when you have to adjust for wheel wear, you're going to loosen up your C and your D so that way your rail can slide left and right as you tighten down the left side. You would adjust the left wheels first to make sure all 3 of those are touching the Z rail, and then you would adjust the right side and then tighten bolts C and D back down again. I know it's a mess, but this isn't exactly the most intuitive design. Now, I really didn't like all that because it means that you'll have to pop your top bar off every time you do this adjustment. So you'll have to do your adjustment to the wheels for wear to make sure that they're all against the rails. And then check your gantry square, remove your top bar, pull that off, and then do the whole like leveling procedure again to make sure that you're parallel. I wanted to cut out as many steps as possible, so this is how I did it. Now get excited, this is our first big modification to the printer. Here goes. I put a hole. I drilled a hole so I could get to the screw. Yes, mankind has circumnavigated the globe, put beings into space, and unleashed the power of the atom. Now, with the help of Harbor Freight, we have the technology wherewith we can place a hole where once there was none. For we choose to make a hole not because it is hard, but because it is easy. JFK, probably. Anyway, it seemed like the most intuitive thing to do. That way, B is the only screw that has to be tight as possible, and then we can adjust A, and then of course we can adjust C and D because those are available to us through the other side of the printer. That way we don't have to worry about taking the top bar on and off every time we have to make adjustments to like either the wheels or the square or something like that. And we don't have to worry about messing up the wheels, like squashing them back onto the Z extensions. So yeah, just what I did. Now, option B in terms of modification are you could flip the A and the B screws, drill larger holes, and then use nuts on the back and secure them some way with like toothed washers so they don't spin around while you tighten them. But the problem with that is they left us very little room behind this gantry here. So there's not a whole lot of room that you have to play with, but maybe you could stick a really flat nut in there. But seriously, like if I had been consultant on this project, I'd have been like, bruh, what? And then there's always option C, which is the other alignment methods. Leave the top bar off, etc., pull it off, put it on, tighten them down, yada, yada. But you can't adjust it on the fly. It takes a lot longer. You risk nicking your wheels as you squeeze them on and off, that type of thing. So I'll show you the 2 ways to do this, one aligning to the bottom, one aligning to the top. And I'm going to flip the printer around backwards so our screw numbering image thing here is going to be mirrored. So remember, our B screw is going to be the fulcrum, so make sure that's nice and tight and Loctited. And you can see right here, everything else is just kind of wambly and loose. Adjust your wheels on the motor side so that they're the proper tension, not too tight, not too loose, and all three wheels are touching. Then go ahead and adjust the same thing on the dummy side, so the non-motor side, making sure all three wheels are touching and you get them properly tensioned. I like to take a silver Sharpie and put a mark on my wheels so I can easily see at a glance if they're rolling or not. So right here you can see they're definitely touching. As I move this up and down, they're rolling. And they should be just tight enough that you can't stop it or roll it with your finger. So once you have that all adjusted, you can start to square the gantry. So if you're using the level against the legs method, just roll it down like this and then take whatever it is that you're using to level it with, like I said, DVD cases or CD cases in my case, slide them underneath and then bring the gantry down against those to make sure that they're level. Then go ahead and tighten down the C bolt, followed by the D bolt. Then slide your gantry up by hand to align the A bolt with wherever it is you have your hole drilled, and go ahead and finish tightening that down, and you're good to go. Slide it back down and remeasure with whatever it is you use to level these out, and double check your work. And alternatively, if you have measuring tools, you don't have to use like CD cases or whatever. You can just use a pair of calipers or your tire depth gauge with or without the patented crap attachments. Option B, measuring and leveling from the top. I prefer this method because I don't have to slide the bed out of the way or worry about like removing the electronics cover or anything like that. But let me introduce you a term from philosophy, logic, and mathematics. And that's IFF, which means if and only if. So if and only if your Z rails are exactly the same length and they're square on the top, then you can use a method that measures from the top bar, which is what I made this little goofy attachment to do. So there's a lip right here that's just meant to ride along the top, and then the little nubbin attachment rides along the gantry to make sure that it's flat. So of course, ideally your measurement on the one side should match your measurement on the other side. I guess that goes without saying, but I'll say it anyway. If you're clever, you can go ahead and put your hole wherever it is you can access it with that little crap measurement John in place. But I was impatient and I put the hole before I made the jig, so you just have to slide it down to match up the screw with the hole and then tighten it down. And conversely, you can do it without burning out the jig by just flipping it upside down, resting the caliper along the gantry, and then measuring up to the top bar like that, in the same way that we would measure with the caliper and no jig from the gantry to the bottom bar. And just a reminder, you can always use calipers for this as well. Flip them upside down and they make a depth gauge. Thanks a lot for checking out the video. Hopefully that was helpful. If you have any questions, leave them in the video description below. I know I've been getting way behind on questions lately, but I'm doing my best. And anything that I miss, even if it takes a couple weeks, I'll try to get back to it. And if I can't get back to it because it'll take too much typing, I'll do it in the next question and answer video, as long as I see it. Like I said before, sometimes they get caught in the spam folder and I don't get notified also of like replies to things that I reply to for some reason. So that all sort of falls through the cracks. And when I have time to rifle through hundreds and hundreds of comments, I go through and try to track down those threads, but you can see how easy it is to miss them. So if you like this content, you want to see me keep making it, check out my support links in the video description below. Like I said, I have Amazon affiliate links to the little gizmos that I mentioned in here. There's also just the general click-through portals where you click through that, whatever you buy, they kick me a percentage. That's the type of thing that keeps this channel going. As well as Patreon supporters, thank you to all of you. Now, hopefully in the next few days, I will be getting out some kind of board review, fingers crossed. And there are many board reviews to come, as I will explain in that video, hopefully, if I get it out by then. So, catch you next video, and until then, get out there and make something awesome.